Shah from El's Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you about test of significance for the difference of means for the large samples from the subject of probability and statistics from the unit of applied statistics. In the last session, I had explained you about the test of significance for a single mean. Now, if there will be more than one mean, then we will take in the difference of this mean. It means we will comparing the number of systems mean. So, if we are defining this test of significance for the difference mean for the large sample. So, first of all, what is large sample? As you know that the large sample means the number of samples are greater than 30. So, for this kind of system, we are defining the test of significance for the difference of mean. So, there are various working rules for this. The first rule is we are defining the null hypothesis, means we are assuming something. Like suppose if I am assuming that the null hypothesis is defining as x0, in this we are assuming that the value of mu1 equals to mu2. It means if we are taking two different means, then we are assuming that these two means are same. So it means we can say that the two samples have been drawn from the two different populations but having the same mean and equal standard deviation. So this one is considered as the one kind of assumption. So it is considered as null hypothesis. Now if we are taking that alternative hypothesis, so as you know that alternative hypothesis means it's a complement of null hypothesis. So what will be the complement of this? If we are assuming that mu1 equals to mu2, so its complement means it will not same, right? So if we are defining the alternative hypothesis, it will be defined by h1, and in this we will taking the value of mu1 does not equals to mu2. And we can also say that mu1 is greater than mu2 or mu1 is less than mu2. So by using this different assumption, we can define the value of null hypothesis and alternative hypothesis. After this, we will define the level of significance. Either you had given the level of significance or you have to assume by default level of significance equals to 5%. So the next step is we will defining the level of significance. Based on this level of significance, we will defining the critical value of z. So before that, we will defining the value of test statistic. So we will finding the value of test statistic. It means z equals to x1 bar minus x2 bar upon under root sigma 1 square upon n1 plus sigma 2 square upon n. Now in this, the value of x1 bar means it will representing the mean of the first population, and x2 bar means it will representing the mean of the second population. Similarly, if we are defining sigma 1, sigma 2, it will be defining as standard deviation for the first population and second population. Now in this, the value of sigma 1 and sigma 2 are not given to you, then you have to use S1 and S2. Now we will finding the value of critical value of Z, which is Z representing as Z alpha. It means Z at the level of significance alpha. Now we will comparing this two value, the value of mod Z with the value of mod Z alpha. And from that we will deciding something. So we will applying the decision from this comparison of test statistics mod Z and the value of mod Z alpha. So this way we can solve any example based on the different means. Now if we are defining some note, in this we are defining the confidence limit. So the first confidence limit is for 95% level of significance. So for that, x1 bar minus x2 bar plus or minus 1.96 under root of sigma 1 square upon n1 plus sigma 2 square upon n2. So by using this value, we can define the confidence limit. So if we are taking the minus values, it will give you the lower limit, and if we are taking the plus value, it will give you upper limit. Similarly, if we are taking for 99%, then this value will be representing as x1 bar minus x2 bar plus or minus 2.58 under root sigma 1 square upon n1 plus sigma 2 square upon n. So by using these two equations, we can solve any example to find out limit of the confidence. Now if we are solving some example, the first example is test the significance of the difference between the means of two normal population with the same standard deviation from the following data. In this, the data is given to like this: sample 1 and 2 are given to you. For that, the size is 100 and 200, mean value are 64 and 67, and the value of standard deviation equals to 6 and 8. So these values are given to you. In this, you can see that the mean value are different for 64 and 67, right? So this data are given to you. So from this, first of all, we will defining which data is given to you. So for that, the first one is total number of samples for the first system equals to 100. For second system, its value equals to 200. So we are taking n1 equals to 100 and the value of n2 equals to 200. Now the next thing, we had given the value of mean. How we are representing the value of mean? Mean will be representing by x1 bar. So the value of x1 bar equals to 64 and value of x2 bar equals to 67. Now the next value you are given is standard deviation. Its value are 6 and 8, right? So we are writing that s1 equals to 6 and s2 equals to 8. So in this, first of all, first step we'll assuming something, so it will consider as null hypothesis. So we're defining that the null hypothesis h0 equals to mu1 equals to mu2. It means we are representing two mean values are same. So we can also say that there is no significant difference between the two sample means. Now this one is a null hypothesis. So what is alternative hypothesis? In the alternative hypothesis, we are representing it as h1. So what is the value of h1? h1 means its value is representing as mu1 does not equals to mu2. It means two means are different. So if we are not taking a particular value, so other than this means it will consider as two-tailed test, right? So in this we can say that it is considered as two-tailed test. We are taking the 5% level of significance. So if we are defining the level of significance, then the level of significance equals to alpha equals to 0.05. Now if we are finding the value of test statistics, then the value of test statistics equals to z equals to h1 bar minus x2 bar upon under root h1 square upon n1 plus h2 square upon n2, right? Now if we are putting all this value in this equation and after solving this, its answer equals to minus 3.31. Now we are taking the value of mode z. What is the value of mode z? Mode of this minus 3.31. So the value of mode z equals to 3.31. Now we are finding the critical value of this. So critical value will be defining as z at 0.05, right? So it will be representing as z 0.05. Mode of this, its value is equals to 1.96. This value will be defining from the z table. So from the z table we will finding the value of z at 0.05. So its value equals to 1.96. Now if we are comparing this two value, mode z with z 0.05, then you can say that the value of mode z is greater than mode z 0.05, right? So from this we can say that the value of mode z is greater than mode z 0.05. So as there is a greater than sign is there, so we can say that the null hypothesis is not acceptable or it will be rejected. So from this we can say that the null hypothesis is rejected at 5% level of significance. And what we had assumed in the null hypothesis, we had assumed that there is no significant difference between the two mean values, right? So it means there will be difference between two mean values because the null hypothesis is rejected, right? So we can say that for this particular example, the number of mean value will be different. So these two means are not same. Now we are taking the next example as the mean and simple sample of sizes 1000 and 2000 are 67.5 and 68 centimeter respectively. Can the samples be regarded as drawn from the same population of standard deviation 2.5 centimeter? So in this we had taken the same population standard deviation of 2.5 centimeter, right? And we had taken the two different population with two different mean values. So in this, which data are given to you? The first data is given to you as the number of samples are 1000 for the first population, and for the second population its value equals to 2000. The value of standard deviation is same, right? So the value of standard deviation is representing as sigma 1 equals to sigma 2 equals to sigma, and its value equals to 2.5. Now if we are taking the value of mean equals to, for the first population its value equals to 67.5, and for the second system its value equals to 68. So the value of x1 bar equals to 67.5 and the value of x2 bar equals to 68. Now we'll defining the first step as null hypothesis. What is null hypothesis? In this we'll assuming something, and as we are taking two different means, so we'll first of all we'll assuming that these two means will be same. So in the first we'll defining a null hypothesis as it will be representing as h0. In this we'll taking mu1 equals to mu2. It means the samples have drawn from the same population of standard deviation 2.5 cm. So in this we had assumed that the two mean values are same. But if we are taking the alternative hypothesis, so in the alternative hypothesis it will be representing as h1. In this we will taking mu1 does not equals to mu2. So it will not equals to some value, so it will consider as two-tailed test, right? So this particular example will consider in the form of two-tailed test. So this will be particular defining for finding the value of mode z for the critical at a level of significance. And in this example, level of significance is not given to you, so we will take in the level of significance equals to 5%. So the next term is level of significance is alpha equals to 0.05. 5% means 5 upon 100, right? So 5 upon 100 means its value equals to 0.05. Now in finding the value of test statistics. So what is the value of test statistics? As you know, the equation of it equals to z equals to x1 bar minus x2 bar upon under root of sigma 1 square upon n1 plus sigma 2 square upon n2. Now in this we will putting this all the value, and after solving this the answer of it equals to minus 5.60. Now if we are finding the value of mode z, its value equals to 5.60, right? Now we will finding the value of z at critical value at a level of significance equals to 5%. So we will finding the critical value of mode z at 0.05. So its value is mode z 0.05, and from the z table for this two-tailed test, if we finding the value of mode z, its value equals to 1.96. Now you can compare this value of mode z with this value of mode z 0.05. So you can see that the value of mode z is 5.16, right? So it is greater than mode z 0.05. So from that we can say that the value of mode z is greater than something. So as there is a greater than sign, so we can say that the null hypothesis is rejected. So it means it will give you two different sample means. So our assumption that the two sample means are same, it is rejected. So we can say that the two different sample means will be there. So we can say that from the same population of standard deviation, it is giving you the two different sample means. In the next session, I will explain you about the same method for the test statistics for the large sample, but for two different standard deviations. So in this, we are taking the same sample mean but two different standard deviations, and how we are solving the examples. Thank you so much.